in this arena. Explore the world of technological possibilities at Tata Power DDL's Learning Center, CENPED, in India's national capital, New Delhi, where you can get the best-in-class technical trainings from experienced power sector professionals. A perfect mix of both practical and theoretical learnings. To our showcase centers like SCADA, ADMS Technology Center, Smart Grid Lab, Battery Energy Storage System, Solar Generation Sites, Grid Substations, Meter Testing Labs, etc. Fully air-conditioned training rooms with all modern teaching learning facilities and state-of-the-art auditoriums for conducting interactive sessions. Live models for simulation and online training, demo room and HOTT Center of Distribution Equipment. Established in 2005 as the Center for Power Efficiency in Distribution, CENPED, it has now evolved into a full-fledged training center with a vision to revolutionize the power distribution sector through innovation, capacity building, and manpower training. Our training options include calendar-based training with site visits based on an annual schedule, customized on-site and off-site training with site visits as per specific needs, induction training programs and refresher courses, customized online training programs, and international study tour programs along with site visits conducted by international subject matter experts. The training center has well-appointed, comfortable and air-conditioned accommodation within the campus for all delegates for residential training programs. Our efforts and results demonstrate that our vision of being the trusted and admired service provider are not mere words, but a way of life at Tata Power DDL, and our commitment to the overall development of the power sector and nation building. Tata Power DDL, with you non-stop.
So that was all about the Learning and Development Center, that is CENPED in Tata Power Daily Distribution Limited.
Then next would be three C's of quality. Next would be the pole number concept. Absolutely great concept that we're gonna discover today. And number four, the sketch tool of GIS and our learnings. But before proceeding further to discuss about the processes, let us understand this word process. Why do we need processes or the process? Right? Most of us, I just got to know about the participant that most of us are from our colleges or something, right? We are still studying, right? So, in terms of if we take example, right, what do you mean by process? Like, we have some targets in our college, like everybody has, like I have to become the topper of the college, or I have to get that job, or I have to start this thing like startup or something. So for to achieve some kind of goal or to achieve some kind of target, what we do, we follow that target, right? We do some kind of stuff like for becoming the topper of the class. What we do, we wake up early in the morning, right? We start to study the books, the materials, right? We start to take practicals, more practicals and more practicals. Then after 2 days, after 3 days, we revise those topics, right? And we give summative assessments, right? Formative assessments and all these assessments, and after that we reach to our target, right? So what we are doing, we are following a process. What we are doing, we are following a process. So we can say to achieve some kind of target, or our target, our goal in our life, in academically we can say, or in corporate we can say, to achieve something, what we do, we follow some kind of process, right? So process is a very important thing, right? And to achieve target, or we can say to sustain that target, right? In the first year we are the topper of our class, because we followed some kind of strong regime, strong study process. But next year we couldn't make it, right? So what we're gonna be result, the result is gonna be poor. We're not gonna get that first rank or second rank if we again did not. Still audio is very low. Why is audio low?
Dr. Pankaj, I would suggest that you connect the audio with the system instead of your the other option. Please check your audio because audio is coming fine to all of us. Yes, please continue.
Oh, thank you. So what we were discussing? We were discussing that to achieve target and to sustain that target, we follow processes. So first of all we implement something, right? Just like the application, right? In application we implement that application, and now from the application to the sustenance of that application, what we do, what we need processes. We need processes to bridge this up. What we need to bridge this up from implementation to the sustenance of that particular application, we need processes. So just like that, to sustain the GIS, from implementing that application to the sustenance of that application, what we do need, we need processes. That's why processes are very important and vital part. Okay, let's discuss what are the processes that we follow in Tata Power DDL. That is, first of all, is asset and network update. This is the number one process. Number two is the consumer mapping process, and number three is the scheme clearance and the equalization process. We are going to discuss all three processes thoroughly. Okay, don't worry. Okay, first of all, the asset and the network. So, what is an asset? Asset is something like transformer, the RMU, the cable, the poles, all the network, right? These all are our assets. Our consumers are our assets. So all these assets. So to map those assets in GIS, what is our process, right? So we're going to discuss that. Second, the consumer mapping, all the consumers which are connected to our network, the mapping of those consumers. Third is the scheme clearance and the equalization. So we're going to discuss what is a scheme, what is this process. We're going to thoroughly discuss this, right? So let us start with first process, that is asset and network update. So we have classified our assets and network in three terms. The first is more than 11 kV updation. So I hope everyone here is electrical engineer, so he knows what is the meaning of 11 kV, right? So more than 11 kV updation first. Second is below 11 kV updation, which is more or less the LV part, low voltage. And third is the consumer updation. So consumer updation we're going to cover in consumer processes also. So but now we have classified these three things for the presentation purpose, right? So for more than 11 kV process, what we have notification system in our ERP, right? ERP is enterprise resource planning that we use. SAP, you must have heard about this SAP, right? This is our ERP here. So in this we have our notification system. What is notification? Just like Facebook, Instagram, we get notified when someone uploads a picture, then we get a notification that hey, this person, your friend has uploaded this, so just like that we have a notification system. Second, for below 11 kV updation, we have LT portal in which the user sends us the information about what he has done or nothing. Right? Third is the consumer updation. For consumer updation, what we have again, we have notification system again in our ERP, right? So these are the three classifications that we have done: more than 11 kV updation, below 11 kV updation, and the consumer updation. For more than 11 kV updation, we have system in our ERP. Consumer updation, again we have notification system in ERP, and for LV updation, we have LT portal, dedicated web application in which the user notifies us. First of all, let us understand the process for more than 11 kV updation. So what happens is, for more than 11 kV updation, let us take an example, or should I say, let us first understand the process, right? Let us understand the process, then we will take example to thoroughly get that. So first of all, we have notification system in ARP. In that, a notification is created for any kind of work or task, right? And that particular thing is done over the laptop or the system, right? Then that notification is given for the approval by the GIS. When the time GIS gives the approval that it's okay, you can do the work, then it is, then the approval part is given to PSC, and further PSC, our power system and control department, gives the further approval for the outage part. Now you can take the outage and do the stuff. After that, that notification comes back to us again, and we update that work in our system. So this is the whole process. And at this time when data is being updated in GIS, this is a hi-fi moment for us. Why hi-fi? Because data is getting updated. Because see, GIS is what? GIS is the storage of data, you can say. And geographically you can store data. For storing the data, we have other mediums also, like we have Excel's, correct? We have Excel's, PowerPoint. In these applications, we store data. So why do we need GIS? We need GIS to geographically locate those data or those assets, right? So data is most important. And at this step, the final step, the data is getting updated. So this is a hi-fi moment for us, right? So let us re-understand this. What is this? So first of all, a notification is created, then approval is given by GIS, then further approval is given by PSC for the outage, and hence the data is getting updated in GIS, right? So let us take an example for this. Let me take my pen. Yeah. Wait. Wait for a minute, just. We'll discuss this process. So first of all, what happens is, just give me 10 seconds. I'm just adding a header here. Yeah, right. So first of all, the first step is to initiate the notification, right? The first step is to initiate the notification, and that status of that particular notification is known as INIT. INIT means the first stage of notification. That notification has been initialized. And let us take an example. The notification is about, let us take it for DT augmentation, right? From 160 kVA to 315 kVA. Okay, I hope it's visible. Yes, it's visible. So a user wants to augment a particular DT at a particular pole, and which the original, or you can say the old DT present is 160 kVA. Now he wants to augment that DT to 315 kVA. So first of all, what he's gonna do, he's gonna initiate a notification, right? And after that initiation, that notifications comes to us, or should I say comes to GIS at the stage of WTNO. At the stage of WTNO, that is the waiting notification. Okay. So after the waiting notification status, what we do, we check thoroughly that what he wants. For example, like he wants to upgrade his DT from 160 kVA to 315, but we checked and we got to know that there is no 160 kVA DT on that pole. That pole number that he's providing is actually wrong. So what we do, we reject that particular case and we send that information to the user. Then user again, after correcting the details, sends back that notification to us. Okay, and if the all details are okay, then we give a approval, and that approval is known as GISA. GIS is basically GISA, GIS approved, right? And after giving the approval, that notification is sent to PSC, sent to PSC for further approval of that notification. Now you can take the outage, you can disconnect the geo switch, and now you can work on this site, you can work on this pole, right? So now at this stage, the user gets the user becomes the eligible for dismantling the old 160 kVA DT and to install 315 kVA DT. So at this stage, what we do, he starts to work on that site, right? So he put the notification status as WIPR. What is the meaning of WIPR? It means work in progress. Now the work is in progress. So after completing this work, what he do? He makes the status of that particular notification as WCAP. WCAP. Meaning of WCAP is work completed as he proposed. As he proposed, he was proposing to augment the DT from 160 kVA to 315 kVA, and hence the work has been done. So now the status is WCAP. And after that WCAP status, that particular notification comes to GIS for the updation part. For the updation. So at the first stage, at this stage, we were giving the approval for the work only. Like what you are saying, you want to install a DT on it, okay, your details are correct. And finally, at this stage, sixth stage, we are updating, or you can say we are inserting a 315 kVA DT into our system and dismantling that particular 160 kVA from our system. I hope you got it, right? So this is the whole process, that how we are updating more than 11 kV updation, right? This was just an example of DT augmentation. This can be of cable replacement, RMU replacement, new RMU insert, geo switch. So more than 11 kV, any stuff, it will go through this process, right? Okay. So now let us discuss about the LV updation, how we are updating LV, low voltage stuff. So for low voltage stuff, what we do is we have a dedicated LT portal in which, first of all, the user or the our operational team, they do their stuff at site. Like they have to install a particular ACB or they have to dismantle a particular LT network. They don't need our approval, right? At the time, they what they do is they do that particular operational change at site. They do that, and after doing the same, then they notify us that we have dismantled that particular LTACB from that site, and now you can update it in system. Then we updated our system. Yeah. So this was the process for LV, and that was the process for more than 11 kV. And again, the data is getting updated. So what is this? This is a high-five moment for us because data is getting updated into the system. That's why. Now one must be thinking that these all were the permanent changes, right? The permanent changes, like we have dismantled the old 160 kVA DT and now we have installed 315 kVA DT. This is a permanent change. What is the process for temporary changes? Because in electrical utilities, we must know that there are some kind of temporary changes that are for few days or few hours, right? So what is the process for that? So those kind of changes which are temporary are not updated in GIS directly. Those are updated to the ADMS part. Yesterday you must have had one session with our esteemed faculty, Ms. Sonam Malik, um, about the ADMS, about the GIS, right? So what is ADMS? It is the Advanced Distribution Management System, whose backbone is actually the GIS data. Okay, but you can do some kind of stuff at GIS, at ADMS panel itself. So those temporary changes are directly incorporated to the ADMS screen, not through the GIS. Correct? Okay. Let's go further. Now the consumer mapping process. So what is this consumer mapping process? It is basically any new meter and a protocol sheet. A new meter which is going to be installed at site in the consumer premise, and the protocol sheet. It is given to our MMG engineer. That MMG engineer, what he do? He installed that particular meter at site, charges that, and hence our consumer get energized, and he captures the pole number through which it is connected, right? He captures that pole number. That details, all the details about the consumer details, its CA number, its load, right, its pole number, all the data is given to GIS via ERP, right? And after that we update that particular thing in system. Like the consumer has a particular, you can say the consumer number, you can say consumer number X, and that X is connected to a pole, nearby pole, the pole number is Y. So those details are given to GIS, that X is connected to Y. We map that particular thing in GIS, and hence the consumer get updated. And again, this is a high-fi moment for us because data is getting updated into the system. That's why these processes are very important, as we are discussing earlier, that these processes are very, very important. Because until unless there is no process, the data will become, there will be no significance of that particular data. It will just become a garbage, right? Now, the important part, scheme clearance and the collation process. So let us think what is a scheme first, right? Any scheme means the suppose we want to install two poles and one HTABC at site, right? So these are the new assets. These are the new assets which is going to be installed. So all these new assets, their services, the labor charge, right? All that comes under a particular thing, and that thing is called scheme, right? Scheme X, scheme Y, scheme Z, these are the names. And in a scheme, there is a particular thing, right? Scheme X has two poles, one transformer, for example. Scheme 2 has cables, right? So any work at site is done against a particular scheme. So all the capex work, capex means the capital expenditure, right? There are two things, one is capex and one is opex. uh, the capital expenditure and the operational expenditure, right? All the capex is involved under the schemes. So any scheme which is framed, like we have to install two poles and one DT, for an example, then that particular thing is executed at site. And at this step, you must be knowing that you must have got it. Key at this step, that execution at site, you need a notification. So for that, you have to follow first process. What was the first process? More than 11 kV stuff or the below LV stuff, right? So the same thing is executed at site, then that data is sent to GIS for the updation part. Then what we do, we verify that. What we do, we verify that. What we verify basically, the BOQ, the bill of quantity that was mentioned in the scheme. As for an example, we can say that a scheme has two poles and one DT, two poles and one DT to install at site. Okay? And same thing is being updated in GIS. Now what we do, we see what are the materials reconciled in ERP or in the SAP, what is it showing and what is updated in GIS. Suppose in ERP it is showing the scheme has two poles, one DT and one HTABC, but in GIS it is showing only two poles and one DT. No HTABC is in GIS. So what we do? We reject that particular scheme. We say to a user that this is the mismatch which we have observed. Now the user reconcile that particular thing in system and makes both same, right? And after the both systems are same, the BOQ which is reconciled in ERP and what the data is updated in GIS, we particularly approve that particular scheme. And after that, the same scheme is capitalized by our finance department. Now the finance comes into the picture, right? Because it's all about the money. The assets we have, which we have installed at site, right, are gonna be capitalized by finance department. But to capitalize that particular thing, particular asset, that the root is from the GIS, right? Until and unless the GIS has approved that particular scheme, you can't capitalize. So this is the process that we follow in Tata Power DDL. So this was the scheme clearance process, right? So after that, when scheme get capitalized. Suppose again we take the example that it had two poles and one DT, and now they are updated in GIS, and hence it has been approved by GIS. and now scheme is capitalized by finance department. What they do is, any asset which gets capitalized, a number is generated which is called the asset number, which is called the asset number of that particular thing, right? The two poles, that means the poles has asset number, the dt has asset number, right? This is generated by finance department, and the asset number which is generated by finance department is again given to GIS. Okay, see, we have generated this asset number X for your this pole, and this asset number Y for your DT. Now you can link these asset number in GIS. Then what we do, we link those asset number to over those assets like DT for RMU for ACBs, right? We update those asset number into our system, and this step is called asset equalization. Asset is getting equalized where? In GIS and the finance, right? Okay, and this is the major step, asset equalization. Scheme clearance and equalization processes are very important processes actually. And again, this is a high-five moment for us because data is getting updated into the system, right? Okay, before moving further, if anyone have any kind of doubt or related to the previous processes, because we have covered all the processes, so anyone have any kind of doubt, please share your doubt. Okay, use system audio. I hope I was audible throughout this session. Can anyone please confirm? Because I'm seeing some comments that is
Pankaj, you're
still not
audible.
audible. Okay, great, great, great. How notifications is sent? Okay, it is sent through ERP, SAP. Let me take you back to the process. Okay, see, this is our screen, that the SAP screen. See, I have one sec. Actually, the chatbot, everything comes into the place. So this is, see, you can say display PM notification system alteration. Here you can say, here is the notification number. Yeah, and it is for DT swapping. Is it visible? Or should I zoom it? Is there an option to zoom? Yeah, right. See, for DT swapping, this is the notification number, and in here in the notepad, what is saying? Nale wala 3 315 kVA DT is to be augmented. Existing DT details are this. So this is how a notification is sent. Clear, sir? Okay, if site details and GIS detail mismatch, who will be verify and approve? Okay, okay. See, if there is any kind of mismatch, then what we, in the first step, what we do is we notify the user that hey, you were saying you have installed this particular DT at this pole, but there is no DT at particular at the said pole. So you must be giving a wrong pole number. So that thing is notified to user via email or via through the system. But first of all, we give the information via phone or telephonically communicate that thing or through the system, and we try least to reject that particular thing, right? So the first step is to notify the particular user that this information has mismatched, and second step, if something big, a big mismatch is observed, like the mismatch in length, mismatch in the names of trunk feeders and all, then what we do a survey, a joint survey, in which the GIS people and zonal people, they both go to the site and do the particular survey of that thing, and then we update that thing in GIS, right? Why can't site people can update GIS directly from web portal? Okay, sir, actually GIS is something which needs competency, right? We have a software called EO Core. It is in the coming slides that we will discuss. EO core, and EO core requires competency, that you must know okay, how to insert a particular asset into the system, how it is how it's going to be connected to the whole network. So that requires a competency, and that's a whole together different game, you can say, or a whole together different task. So our zonal people have other tasks, other priorities, right? So for that we have a separate GIS office where you can send your notifications, and we will thoroughly read your notification and we will update that thing in system, right? That requires competency. What is the difference between asset and network? Okay, asset, we can say that a particular transformer, right? The HT cable, but these all are my assets, right? If I say individually, like transformer, RMU, asset, LTACB, okay, right? These are my assets. But when I concatenate them, like I have a grid, a feeder is coming out of the grid via poles, and at the X pole there is a DT. So this is the whole hierarchy of the thing, all the assets. Now this thing will be said to be network, right? When I concatenate all those things, when I make a hierarchy, that makes my network. An asset is basically individual, like geo switch, LTACB, transformer, cable. This is my asset only. But when I see the hierarchy, that from the grid, my cable is coming over the poles, and there is one DT connected to it. So that is the thing. I have understood planned shutdowns. Okay, great. Do we have something for LT also where customers are notified? Yes, 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 absolutely. Via ADMS. Why ADM is when anything which is planned, like we have an outage for a particular DT, then what we do, we let me take you. Achha, we are in the same slide. Okay, see here, this is called approval by PSC, right? So at this stage, what PSC do is PSC notify all the consumers that for the next 2 hours there is going to be an outage. Because how they are notifying? Because they have been notified that we are going to do some kind of work at this particular pole. So they notify all the customers that this DT is going to have outage for at least 2 hours or something. So you must do your stuff. So this is how they notify. But for LT, the shutdown is for very less time, very less time. Just you need to replace those ACBs or something, so that requires less time. Yes, through SMS only. Yes, absolutely correct. SMS. Great, great, great. In telecom pole, network etc. called inventory. Okay, but same in power sector called asset network. Any comments? Inventory is something which is called, you can say, the data of all the assets, right? The counts. But in telecom, sorry, I don't have knowledge about this. Okay, in telecom, the network etc. is called inventory. That that thing also must be said, na, ki it is a network only. But sorry, I don't have knowledge about this. Okay, the assets or the network on the telecom pole is called inventory. But I'll definitely do some kind of research over it. Okay, is it the inventory or something? Okay, great, 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 great. Fantastic. May I know, Samant, through SMS or Munadi? What is Munadi, or what is Munadi? Just for the knowledge. How load management. अच्छा हिंदी वाला Monadi. Okay, okay, okay. Monadi. Okay. Maybe शायद the message one ना, right? Okay. How load management can done if any failure occurs in any feeder and utility want to change the load in other feeder. That's an absolutely great question. Great question. Okay, so we have ADMS, Advanced Distribution Management System, and if suppose there are two kind of things, one is planned and other one is unplanned. Like uh, we see that there is a growth in a particular area, the load growth, right? So then we plan, okay, let's augment those DTs, or let's lay feeders over this area. So this is called a planned. So for planned, you have a planned thing, right? The asset, and you create a task, then it is approved by GIS, then the approval part and data hence get updated in GIS. But what is the thing if there is any failure, the real time failure, right? So in case of any real time failure, the more than 11 kV and you can say correctly EHV, extra high voltage assets, those assets we have stimulation over the ADMS system, and we get notified when any kind of EHV assets get damaged or there is any kind of failure, then we get notified and then we work on that. But for below 11 kV or the 11 kV, we don't have any simulation over the ADMS screen. Then what we do, our zonal person take care of that. That they go to the site, they repair that particular feeder, or if they want to change it, they change that thing in that emergency situation, and after that they notify to GIS that we have replaced this feeder or we have done this thing over this thing, and now you can update it in system. Then after we do. So in case of emergency, because these are the system constraint, that our first priority is to energize, restore the energy at site. So first priority is that. So what we do, we don't go for the approval part, we just do the work at site and then notify to GIS. But in case of planned thing, in case of planned thing, so planned thing mein, we go through the processes part, right? Okay, Monadi was verbal communication through loudspeaker. Okay, okay. Thank you, Saman. Thank you very much. It will automatically update while calculating DCL. DCL is Mr. Fulchand Ahirwar. Distribution commercial loss. But that's a end thing, no? Distribution commercial loss, that's an end thing. That we calculate that thing that we have got this commercial loss. That's an end thing. I'm talking about the real time updation. Okay, right now my fader got interrupted or my fader got damaged. So what we do in GIS perspective. So at that time, our first priority is to restore energy. We restore that particular thing, we change that feeder or we make a joint over it, and after that we notify to GIS, right? And commercial loss is a different thing that will come into the play after this. Okay.
बरोबर.
Yes, Saman. In plan shutdown we SMS customers. Correct. We are exploring this. GIS has IoT, Internet of Things. We are exploring this, and we are glad to share this. We have ADMS, the most advanced distribution system we have right now, and we are working. We're still exploring this IoT, Internet of Things. We are still exploring this, and yes, we are exploring this. Load forecasting also possible, na? Yes. Load forecasting absolutely possible. But that's the part of our PSC team, not of the GIS. That our PSC does that stuff, load forecasting and all. Okay, let's move further. Let's discuss. Now, the three C's of quality for GIS, that how we are maintaining the quality. The first C is the coverage, and this is the most important C. Why? Because we have to cover all the things, the coverage of data, the coverage of data. Second C is the conformance, that what we have received through our users, we have to conformally update that in system, right? All end-to-end connectivity, all end-to-end connectivity of that particular thing. So we have QC routines for it, quality check routines for it. And last is the output. Output is the basically our operation system, that is ADMS. ADM for ADMS, GIS data is the backbone. GIS data is the backbone. So there must be quality in the GIS data, right? So hold on for 1 second. My laptop's battery is going to shut down. Just hold on for a minute. Yeah, right. So first C was the coverage of all the data. The second C was the conformance, and the third C is cycle time. Why cycle time? Because you must have heard the data delayed is actually the data denied. I'll repeat this thing again. Data delayed is actually the data denied. The If we cover all the data, right, we are covering we get data from our users, and we are not updating, or we are not able to update that data into the system in a particular SLA or in a particular cycle time, then data is of no further use, right? So we have to cover all the data, we have to make QC routine for it, which is called conformance, and third is the cycle time, is to make data update into the system really fast, right? So coverage, we have new work execution which is being done at site, all the new connections, and all the operational changes. All the operational changes. All the new work execution is just done through scheme clearance, which we just discussed. New connection is all about the consumer mapping, and operational changes are the operational changes, right? Second is the processing part, the conformance. For conformance, we have QC routines, quality check routines into the system itself. The GIS has its own QC routines. Like there is a part called circuit build. Uh, I don't know, you must be knowing this or not. That in GIS, what we do, we make a design. We make a design, and in that design, we insert, we delete, we update the assets, right? Here you can see this is a circuit breaker, this is the transformer, this is the LTACB. So first of all, let us understand that there was no ACB here. Let us think like that. Okay, there was no ACB here. So first of all, in updating into the system, what we do, we make a design in GIS, right? Just like a project, just like a project. So in that project, we insert a particular ACB. Here you can see we inserted a ACB, and we connected a cable to the DT, right? Then we process that design. And in processing of that design, the GIS software, the EO core itself, EO core itself drives the quality check itself, like end-to-end connectivity. कि is this connected with the DT or not, the LTCB or not, ये ऊपर वाले से connect है या नहीं है, all this connectivity is done in this QC written by the software itself, right? Second, we have workflows. For GIS people, we have workflows, and next is the capex checklist. Capex checklist is almost same, or you can say the same, like scheme clearance checklist, that we have to verify that this thing is in CGI, SAP, and this thing in GIS. That's a checklist, thoroughly checklist, right? A thorough checklist. So these are the part of conformance. And last is the synchronization. Synchronization between two systems. One is GIS and another one is ADMS. All the data from the GIS reach to ADMS. And this is measured by our KPIs and daily work management, right? DWM, daily work management. So this was all about the 3 C's of quality that we maintain, right? Next, moving on, the most wonderful and the awesome concept, that is pole number concept. Okay, let me know. Can anyone share how many people are from this TPDDL constituency only, or I say Delhi? how many of us are from Delhi or in Delhi, in the TPDDL area? Anyone? No? Okay. No issue, no issue, no issue. So what is the pole number concept? So any pole which is installed at site, it has some kind of nomenclature. It has some kind of nomenclature. So what is the nomenclature? For LT poles means the LT network poles, right? On which the LT network is going is known as LT poles, and its height is generally 9 meters, right? And for HT pole, it is the high tension pole, which has height 11 meters, right? So what is the nomenclature? The nomenclature is, first of all we put the zone number. First of all we put the zone number. We have, what we have done is we have decided, uh, you can say, we have whole TPDDL network, right? And we have divided into the circles part, right? The circles. And after that circle we have districts, and after districts we have zone, right? So any pole which is installed at site has zone number. Firstly, in prefix it has zone number, then dash, then the number which appears is the road number, that, like, in that zone what road number is that on which the pole is going to be installed, right? Then a bigger slash, and then the pole number. Then the pole number. Pole number means it is the first pole, second pole, third pole. Which pole is that? So that is the pole number. So nomenclature is, first of all we put the zone number, then we put road number, then we put pole number, right? We will do some kind of examples here. Then what is the nomenclature for HT poles? For HT poles, we just put a HT in the prefix, right? HT, zone number, road number, and again the pole number, right? Then any T off, whenever any T off is taken, then that is denoted by a slash, and that is denoted by a slash. Like for an example, there is a zone number called 421, and suppose for an example it has road number 22. Okay, let me draw this. Sorry for my bad handwriting, because I'm writing this with my mouse. So 421 is the zone code, then I have put in here a dash, then the road number, suppose the road number is 16, right? And on the 16th road the pole is second. The pole is second. So this is the pole number of that pole. That means there is initially a pole whose number is going to be 421 dash 16 slash 1, and after that 1, this is the 2. I hope you got it, right? This is the 2. And suppose here we have pole 3, here we have pole 4, and I have made a D off here. So this line depicts that the pole number of this pole is going to be 421 dash 16th road slash 2, and then we'll put a slash that 1. Okay, so this is because the T off is from the second pole, so the numbering will starts from here, slash 1, and after that the same, this is going to be 2, the next is going to be 2 slash 3. Simple, right? Okay. And 2 or 3 poles having different code numbers can't be allowed on one road, which is quite general, right? On the same road, this is the road and this is the 16th road. On the 16th road, we can't have no number like 17 or 18. We can't have the duplicacy in road numbers, road codes. Okay. Let us understand this thoroughly on the next page. So these are some of the examples. Like for any LT pole or the feeder pole, first of all, this is the zone code 551, first road and first pole. For HT poles, HT is the prefix, HT 551-11. For street light, which are exclusively for the street light, SL 551. Now one must be thinking, what is the process for the pole number if the pole has LT network and street light network also, right? One was thinking. So simple process. Suppose the pole had LT network initially. So the pole number is going to be this 551-1, and after that a street light network is also laid on that. So what we do in specification part, we put LT plus SL in specification in GIS, right? We don't paint that thing accordingly, but we do this thing LT plus SL. And now any pole which pertaining to unelectrified area, we have started to put a prefix which is U551/1. So these are the pole number concept which we do at site and in GIS. Here are some of the photographs. That's why I was asking, can anyone who's residing in Delhi can easily relate to these pictures, and they must have seen these kind of paintings over the poles. Here you can see HT, that means this is a 11-meter pole which has 11 kV network. 533 is the zone code. Dash 33, that means 33rd road slash 47th pole. Then after the 47th pole, there is a T off, right? I hope you are getting this. Sixth pole, and after the sixth pole, the third pole, and after the third pole, it is the eighth pole, right? Here also 521 the zone code, 4 is the road code. Then after the 10th pole, there is a T off. Let me make this 4, 10 and 18. That means here will be 4/10, 4/11, and after this 10 there is a T off, and now this is 4, 10, 1, right? And after that, lot of poles, there comes our 18th pole. And likewise for 18th pole, say new numbering got started 21, 22, and after that 27, and after that 5th pole. So this is how we assign pole numbers. A simple code, that is, first of all we put HT or the prefix part, then the zone code, then the road code, then the pole number itself, right? We have some examples here. Suppose we have 33/1 and 33/2, and after few months we need to install a pole between them. Now what is the concept, what we are going to do? 33/1, 33/2, we have to install a pole in between them. So what we do, we put a English, or you can say English letter, that is A. 1A, 1A, there is no slash in between. 1A, right? 1, 2, and in between them 1A. Suppose here 504, 12, 13, 2, 13, 3, 13, 4. A T off is made. Now a new pole has been inserted, whose pole number is gonna be 3 hai, then the number is gonna be 3/1, and after that 3/2. Yeah, great. So now I have a question for you guys. You tell me, this is a network HT411, that means 411 is the zone code, 12 is the road code, 13, 27, these are the pole numbers. So I have a network 27, 28, 29, then I have 30 and 31. Suppose I have inserted 3 poles. One is A, other one is B and C. Can you please tell me what is gonna be the number for A? First of all, for A. Ravi Nayak, very fast, great. 29A for A, absolutely correct. Very good, Fulshan, 29A, absolutely correct, great. All of us has to answer this question. Upender ji, 29B, okay, 29B. Upender ji, why 29B? It should be 29A, no? Because there is no 29A in the system. So first of all, we have to go alphabetically. First of all, we will insert A. And suppose after some times between this pole and this pole, a new pole is inserted. Then we will put B here, right? 29A, great, great. You guys are lovely, yeah. 29A, Harsh Ojha ji. Okay, for B. Oh, great. Okay. Now tell me the answer for B and C. B and C. 29/1 for B. Okay. 29/2 for C. Okay. Renuka has given the correct answer, 29A. Fulchan ji, 29/1 for B. Great, great, great. But I want more answers. We have 22 participants, but I got only 4 to 5 answers. Come on. "29B". Okay. 29B. Uh, Srini, for what pole? It is 29B. For A. For B. Okay. 29B. Okay. Madhusudhan, 29A. Okay. This must be for A pole, na? 29A for A, 29-1 for B, and 29-2 for C. Absolutely correct, Razazi. Absolutely correct. Okay, Madhu. Great, great, great. Now, Madhu, tell me for B and C also, please. Upendra ji, can you please tell us the answer for B and C also? Tarun Kaushik, 29A for A. Absolutely correct. "29-1". Okay, we don't need to put dash. We will put just a slash. Slash 1. Dash comes only one time at the starting only. Can anyone tell me at which road we are in? At which road for this given example? 12, absolutely correct. Correct. 12. Great. 12 for 2, okay. 20 and 1. Great, absolutely correct answers by all. Great. SVR Lakshmi ji, 12. Yes, absolutely correct. 12. Yes. 411 is the zone code and 12 is the road code. 13, 27, these are just the pole numbers. है ना? And HT is the prefix used for 11-meter pole. So, as there was A pole, so A was coming in between 29 and 30, so we have put a pole number 29A. We could have put 30A also. Anyone must be thinking we could have put 30A. See, ultimate goal is after 30. Very good, very good. Our ultimate goal is not to duplicate the pole number, not to duplicate the pole number. Very good, very good. So 30A will come after 30, because what is the convenience that we have in anything? We go from left to right, right? And we love to do that, from going left to right only in anything, right? So for A we will do 29A only. Very good, absolutely correct. And after that, for B and C, as B and C are the pole which are installed through the T off from the 29th pole, that's why their number is going to be 29/1 and /2, right? Tell me, suppose if I have inserted a pole between B and C, so what can be the number? If I've installed a pole between B and C, just write the end part only. Just write the end part only. Okay, 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 okay. So B was 29/1 and C was 29/2. The question is, if I have installed a pole between B and C, what can be the number? Some people got confused between B and C. They thought B/1. Okay, I've corrected this. The B pole is 29/1 and C pole is 29/2. Upender 29/1A, absolutely correct. Renuka 29/B1. No dear, not /B1. It's gonna be 1A, because this is A, this is 1. So after 1, as this is the mid pole, so we're gonna insert A, just a letter A. Ravi Naik, this is not gonna be /A. We put slash when there is a T off. When there is a T off, then only we put a slash. Right. This is a mid pole only, no? So mid pole, we will put just a letter A. So let's discuss an interesting question. Let's see what answer will be given by you all. Suppose we have two poles. This number is 3. This number is 4. I have inserted one pole here. So let me give you the answer. It's gonna be 3A, right? It's gonna be 3A. Clear? So now tell me, if I insert a pole between this, so what can be the best answer that we can put in? Between 3 and 3A. 3A dash. Okay, great, 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 great. It's a dash. A dash. Okay, okay, great. Or 3A, a small a. No, 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 there is no significance of small a. And there is no difference between capital and small. So, very good, very good. You tried, very good. But think more, think more. Tricky one, right? Tricky one. But these are the practical scenarios, no? 3AA. I got a lovely answer from Siddhant Prakash. Yes, it happens, yes. 3/A, 3x. Oh, great, 3x. Okay, 3x. 3A star. Okay, lovely, lovely, lovely. 3A dash. Okay, great, great, great. I got one answer from someone. Let me see who gave it. Siddhant Prakash gave it one answer. That was 3A and one more A. Yes, absolutely. This is the correct answer. Now think again. Let us think again. All of us, right? Think again. What was the process? If 3 and 3A has this pole, so what we are going to do? We're going to put a alphabet letter. But this pole has itself the letter A. So what we have done now? We have just put another A. And this another A signifies that this is actually the mid pole. This A is actually the mid pole. 3 double A is actually the mid pole. Right? Absolutely correct. Absolutely correct. But the creativity is great. Many people have put in the slash, dash, star. Great, great, great. Absolutely correct. Very good. Thank you. This was lovely. Okay, let's move on. I hope this thing is clear. Anyone has any kind of doubt here in terms of poll number? Please share. All clear. Okay, great, great. All clear. I had poll loading. Okay, okay. Poll loading. Poll loading. Poll loading is nothing. Poll loading, you can say DT loading something, but poll loading is nothing. I haven't heard of this thing, poll loading. But DT loading, I have heard. Upender, do you know something about this? Can you enlighten us? Poll loading. When too much of conductors or too much of HTABC are laid on a single pole network. I hope that is not the answer. Has anyone heard about this pole loading? The load on the pole. Poles have parallel run for effective services. Yes, yes, yes. Absolutely correct. This is interesting. Let's do this thing. Suppose let this is the parallel run. One pole is here, one pole is here, one pole is here. So in a street, these are the two parallel networks which are going. So numbers क्या होंगे इनके? What numbers can we assign to these poles and these poles? Simple. This is the T off by 28th. So these numbers is gonna be 28 slash 1, 28 slash 2, and 28 slash 3. And this has T off from 29. So these numbers are 29 1, 29 2. Okay. How far a pole has to be? That's in the electrical rules, Mr. Samant. That's an electrical rule, right? Not of a GS perspective. What is a T off? Okay, T off is nothing. Just like you can say a network is going like this, and in this street, you want to install poles and give electricity connection to this house. So what you're going to do? You're going to do a lay a cable here. First, you're going to install two poles, suppose. Then you're going to lay a cable here. You will tap that cable with this cable, the existing cable. This is called tapping. And after that we will take cable here, then you will give connection to this consumer. So what has, sorry for my drawing, what is this? Now this has become a T, that's why it is called T off. Clear? I hope it was clear, right? Rohit. Mohammad Afreen Raza, 40 meter approx. Okay, how far a pole has to be from us? Not exactly 40 meters. 40 meters is actually the more distance we can say, but mm, that's in the electrical terms, right? An electrical engineer has to answer this. It's nothing but the main line is per line. Yeah, right, right. Great, 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 great. Okay. Any more doubt regarding this pole number concept? Shall we move forward? Okay, let's move forward. These were the answers which were already given by you guys. Absolutely correct. That was 29 slash A. Let me erase these slide. Huh. 29 slash 29A, 29 slash 1, 29 slash 2. Already given by you. Lovely, lovely answer, lovely response. Now moving on to sketch tool of GIS. I think this was already been covered by our last faculty, Sonam Malik. Do we really need to go this again? If anyone feels so, please say. If a pole is fallen, do we give it the same number? Yes, absolutely, Samant. We give the same pole number. So same pole number. No issue in that. Significance of zone code in pole number concept. Okay, so basically zone code is the address of that pole number. Zone code is the address of that pole number, right? So suppose the person is saying that is the 12th pole which got damaged. So the other question or the frequent question of mine will be of which zone, right? So the moment the person is saying कि 422 slash 1 slash 23 got dismantled, now I know कि 423 zone का पोल मेरा टूट गया है. Clear? How we know the DT code feeder name from the pole number concept? Oh, sorry. Unfortunately, we cannot. We cannot. But in GIS, what you can do, you can trace that pole number, right? How you have the pole number, suppose, and you want to know which DT's feeder is coming over this pole. So what you're going to do, you're going to just trace that network upward or the downward, and you're going to get the same. That's the you can say the trace tool of GIS. You want me to show it? The trace tool, Muhammad Afreen Raja. G. Srivaslu, polls will have IoT in future. In future, the possibility is yes, but we have to see what will be the significance of that particular IoT over the polls, right? We have to see the significance. If there is no significance or nothing can be useful um, grabbed out from it, then there is no use of IoT for polls. But if it has the simulation, then we can definitely explore that. Okay, let me show you the trace part for Muhammad Afreen Raza because it's actually the interesting part. Okay, let me show it. I need to stop this sharing. Done. This is the trunk feeder name. Port code grid to volt zonal office sub feeder. So the basic knowledge I can get from this only. The attribute itself. Like this is the HV conduct. Right? This is the door conductor. But suppose I want to trace it. So I'll just simply click on this. You can see here send to trace. Single click. This is a 11 kV MV network. So I'm gonna put a MV network upstream. These are the options basically where you want to trace it. As this was the 11 kV network, so I have to put in MV. If it is of EHV, then I have put in here HV. And if it is was of LV, so I have put in these two. Like here you can see trace LV network downstream to customer. So it can downstream to customer also, right? But first of all, let us trace it upstream. Okay, I'll just put run here. We'll hold on for a second. Now you can see the trace has successfully completed. Now you can see this network, the network just we show here, is has been highlighted by the orange color, right? And its route is like this, coming from this, going from this, here, and from which grid this is coming out. Here we can see the Put Khurd grid. This is one of the grid. So from this grid, this asset is coming, and the details you can download it from the export. You can download to Excel or CSV format, right? All the networks. So this is how our trace tool works. Let me show you something more interesting. Let us trace a LV network up to the customer. Let me open a perfect example. Okay. See, here is a DT. This is the substation boundary, the blue highlighted part. This is the pole HT 521 46855. Right. This is a 400 kVA DT. Okay, this is the assembly or the topology for the DT. You put a click here like this. Then you put this trace. Right. Now we want to trace this thing to customers. So let me click on this thing. The wire segment. This is the LV network. I want to downstream to the customer. It will take a couple of seconds because it's about the customers. Mobile number of customers are maintained by ERP or GIS? By ERP, not GIS. GIS only update that into the system. It is done by ERP only, right? And if you have a number, you can search the customer through number also in GIS. I'll show it. Okay. That is the table basically in which the number get changed. So it will come into the table only. It's non-relevant to GIS. So here you can see this was the DT that we traced, and here you can see its network. Its network is totally spread out. You can see in which area its network is going. You can clearly see, visualize, plan accordingly. These are the features of GIS. You can also download the all report from export. See, isn't it interesting? So this is the trace tool, the trace feature. Okay, let me show you the number feature for our brother Samant. Suppose we have a number called 98212. I don't know, I'm just randomly typing this 45205. Okay, we have. So you can see I have just typed here number only, and now I have a data. Whose data is this? This is a customer named Mr. Vikram Singh Minhas. This is the number. This is his CA number. This is his installation number. So you can get the details also from the number only. He is active and he is here. Now we are watching him. Done. So you can also search the customers through their numbers or through anything. These are the customs reports that we have. Let me tell you one more interesting feature, that is neighboring DT. Neighboring DT. See, suppose here is a building B slash 2, and I want to plan, or you can say I want to know how many DTs are there in the buffer of 100 meters of this building. Clear? I want to know the number of DTs uh, in the buffer of 100 meter from this building. So I'll just put a buffer of 100. I'll click on get neighboring DT. Now see the magic. Here you can see the whole list of the DTs that we have. We can also export it. Let me tell you. See, these are the DTs, life cycle status of those DTs, the name of those DTs, district, zone code, plinth mounted or the pole mounted, what are they, distribution, their rating 990, 630, phase, number of customers they currently have, and the distance from the selection. What I had selected the building only. So at a distance of 86 meters there is a DT, and if I want to reach there I can simply go by just clicking on this, or I can copy this, right? See, here is the DT. Now I can plan. So these are the tools which actually help us for technical feasibility of a particular customer that we receive. So this was it. One more interesting thing that we have is the sketching tool, right? uh, Yesterday you had the session about it, no, about the sketching tool. Yes or no? Yes. Okay, 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 no issue. So we'll not touch this upon. Anyone want to revise it? Anyone who missed it? No? Okay, great. Okay. Yes, please. Okay, Ravi. Okay, fine. So, what is this sketch tool is basically, in the processes part, we discussed that the user provides us that at this pole I am doing this thing. Suppose he has laid 100 meter of cable. So, how will a GIS person will know ki where is this cable? Where is going to install that particular cable geographically? So, the user gives us the sketch, and he does not do that sketching on a rough paper, right? He does that sketching on the real time geographical data, right? So what he do is he put this draw sketch, because here these are the tools: point, suppose this is the line, polygon. So basically GIS works on only three things. First is the point, second is the line, and third one is the polygon, right? So suppose I have installed two poles. Okay, let me take you a small example. Let us do this thing at a empty area so that we can draw a good drawing. Let us do this here. No, not here. So let us do this thing here. So I have, suppose, a pole. So what I do, I'll put a pole here. Okay, I need to change the symbol. This is the symbol for pole. So I'll do this pole. See, I've installed a pole here. Suppose I've installed four poles, right? Now I've installed a cable also. So I'll put like this. This is my cable, right? So you can also see कि here's the length coming 94 meter. Here, देखो 227 meter at the real time when I'm doing this stuff. See, so this is how he draws the cable. Not exactly like this, obviously. We're just practicing. So this is how he draws a cable. Now these are the vertex that has been formed. Now he can also move these things from here like this, like this. Obviously network is not like this at side. We are just moving things around. So this is how he draws the network. After he draws the network, he gives us the basic information like on which zone he has done this thing, what is the notification number or the LT notification, is this a scheme proposal or he wants to just correct the data. So and then he provides the notes, right? Suppose LT network he has laid with the cable. Cable is suppose 4 core 25 square of length. Suppose the length is 100 meters, so we'll put this here 100 meters, right? And also 4 poles and 4 LT poles, right? So after giving this information, he submits this, and after submitting this, let us submit this. Okay, now see, please enter all required details. Okay, we have missed it here. Suppose the notification number that he has generated is 4231. Okay, so submit. It will take few seconds. You must have good internet connectivity. No? I think some issue has occurred. Okay, I think development team is doing something over it. So this is how a sketch is drawn. Then after that, a number is get generated. Okay, and the number is shared to GIS. That this is the sketch number that we have linked with this particular notification, and they provide that, and we visualize that particular network into the system, and hence do the approval part, right? So that was the sketch tool. Let us move on to further GIS system at Tata Power DDL. Yes, these are the three systems that we work on. First of all is the desktop, where we do the insert, delete, or the update part. All the core work, right? Which need competency that we were discussing earlier, right? This is the desktop. This is readable and writable. This desktop is readable and writable both. Next is the web application that we just had a glimpse about. That is the web application that is read only. That is read only. Last is the redlining, and redlining was same the sketch part. Okay. Earlier we used to have a redlining separate redlining client. Now we have sunset that thing. Now we have come up with this new thing which is called sketch that we just discussed. So basically, GIS has these three systems. First is desktop, second is web application, third is the sketches part, right? So desktop is basically what? Desktop is readable and writable. Web is what? Web is only readable. And sketches, you can say, you just draw the sketches just like MS Paint tool, right? How can we Okay, we got a question. How to access web application? Okay, web application, it is for the Tata Power people only. They can only access that because it's on intranet, not on internet. Okay, that's a simple thing. I'll just show you, but that will be of no use because that is on internet, intranet, not on internet. This is the see EGS login. This is the TPD WebGIS. Here you need to fill your password, then put this, and now you are into the system. See, but it is for TPD people only, the company people. Okay. Okay. If any pole need to be replaced or cable replaced, is field guy can update directly in core? No, 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 Upinder. He can't. How field person update maintenance? He can't update that directly into the core. He sends that information to GIS and how to do sketching and all. For the sustenance part, which is most important, we have a core team and we adapt to new technologies, we explore new technologies. Just like Tapopan, we launched it last year only. Before that, we didn't have the centimeter accuracy. But from the past year, now we have centimeter accuracy, or you can say we have started to gather that centimeter accuracy level. Okay, in WhatsApp we have accuracy about 4 to 5 meters, but now via Tapopan device, now we have the accuracy of centimeters, like 2 centimeter, 3 centimeter. Where the cable is, we know that, right? And the processes for the sustenance part. For measurement, we have KPIs defined and GIS data quality index, right? Now this is the quiz time. This is the most wonderful part. Okay, Upender got some questions. What are the main challenges with the GIS system? Absolutely great question. Great question. We love these challenges that we currently have. The main challenge is the you can say the real time thing. The real time thing. Real time things. The changes which are being done at site must come to GIS in real time. That is the main challenge, and that is the thing that we are exploring. How we can get the data that this change which is done at site is now live on the system. That is the biggest challenge for us. First of all, that's the second is the emergency. Whenever the emergency comes at site, the transformer got faulty or the feeder got damaged. See, those changes come to us after few days, like 2 to 3, 4 to 5 days. Our challenge is to get those data. Second, third is the incremental changes. For the incremental changes, we have notification system that is quite strong system. But again, when an emergency comes, that system is get somehow you can say delusionable. So that those are the main challenges for us for maintaining the data and all. Right, Upendra? Pole numbers be cement or steel, both get similar number. Especially we use cemented poles. Steel poles, yes. GI galvanized iron poles, yes. If it is in the network, then it will be numbered, right? Okay, मैं काफी पीछे आ गया questions में. Any free GIS software available? Okay, QGIS is something which you can explore. QGIS, Map My Info, Map My India, or Map Info. I think Map Info. These are the software, but these are not. These does not have that. You can say the features that are of the paid only. What about the tagging of service cable? There is no such kind of tagging for service cable. We what we do in GIS we have, but at side we don't. In GIS we mark those service cables with blue color, light blue, बिल्कुल light blue, ठीक? And we don't digitize them. The system generated itself the service cables. We update network cables manually by one by our hand, and for service cables the system generates it, because for ADMS does not require any service cable, right? Okay, we discussed all the questions. Great. Now, actually, we have one question. Mohammed Afin, how we did the consumer indexing on fourth, 10th floor of consumer in GIS? Okay, see, GIS is currently is only 2D is of 2D only. It's not of 3D. See, if a consumer is at fourth or the 10th floor at site, so what we have it his CA number only. So we map that CA number, not the floor or anything. We map the CA number in GIS. If we have CA number, that means we have everything about the customer, right? Do you see any problem syncing data with ADMS and GIS? If so, what are the data issues? Not actually, no such kind of issues right now, the thinking, but at the beginning it was a task at the beginning, because we used to have GIS only at the starting. But after that, when we implemented GIS, then we need to transfer all the data from the GIS to the ADMS, and ADMS itself has its own, you can say, environment. It cannot have all the features of GIS. So at the time of implementation, we had issues, but right now everything is smoothly sailing. Okay, great. So let's get to the quiz. So what we need to do in this quiz is, these are the four questions which obviously have four answers. So you need to answer these questions to yourself only. After that, I'll display the correct answers, and everybody is gonna get have some score, right? If someone got one answer correct, so his point is one. If someone got two answers correct, his points are two, and if someone got all answers correct, then his point is four. So what you need to do is, when I'll display the answers, you need to put your score in the chat box. If someone got all four correct answers, then his score is four. Right? I hope it's clear. Right? Read the questions thoroughly. I'm giving you 1 minute. Are we leveraging huge GIS data with artificial intelligence technology? If so, where we can use AI in GIS space? Now, currently, what we are doing is, we are analyzing where AI and machine learning can be used in GIS data, right? Just like, how many customers, or see, there is one kind of complaint called NCC, no current complaint, right? We are using artificial intelligence for it, right? How many duties